guys. Hi. So you were copying your notes, yeah? Okay. So last time we were together, we were talking about rectangles, and we discussed that rectangles look like my cell phone, right? So they're parallelograms, and the opposite sides are congruent, and opposite angles are congruent, and consecutive angles are supplementary, and opposite angles, I said were parallel, right? Okay. In addition to all of that, rectangles also have each corner be 90 degrees. One, right. Thank you. So today we're going to add to it. Not only are we going to talk about rectangles, we're going to talk about rhombi and squares. They're like cousins. Okay? So a rhombus, oh wait, copy. A rhombus is going to be a parallelogram, so it has all of the properties of parallelogram. Yeah, opposite sides are parallel. The opposite sides are congruent. Opposite angles are congruent. All of that. But all four of its sides are congruent. Okay? So this side is the same measure as this side, which is the same measure as this side, which is the same as this side. Okay? All four sides are congruent for a rhombus. Now, in addition to all of the parallelogram properties, we have two others, and they talk about the diagonals. The first one is that the diagonals are perpendicular. That means that right here at the corner, they form a 90-degree angle. Juan, I need you writing and copying to your notes from my notes, please. Okay? I gave you a copy of the notes, so you don't have to look up here, so that you can copy from there. Por favor, copias del papel que te dijo. Okay, do it. Write it down right now. We're waiting for you to write. Thank you very much. In addition to them hitting in a 90-degree angle, the diagonals, the lines that go from corner to corner, are going to bisect those opposite angles. Okay? What this means is, if you zoom in on this picture right here, means that this angle is the same measure as this angle. And this angle is the same measure as this angle. And this angle is the same measure as this angle. Like, you see how that works? Okay? You can leverage this, bless you, to find out all sorts of interesting measurements about this shape. Okay? Bless you. Now, yesterday in our notes, we had discussed that in order to decide if something were a rectangle, and I'm going to pull out my notes from yesterday, we had to do all of this mess. Like, you remember this from yesterday? Yeah, you were asleep, dude. Rewatch the video, man. Remember this? And a lot of you guys are going, oh my God, this was just a lot of work, right? And it took us like almost the entire class period to do all of this, right? It was annoying, okay? Here's the good news with the rhombus. Once you know this thing is a parallelogram, either you've done this slope one, which most of you said was the fastest, or you were told, hey, this is a parallelogram, then all you need to do to confirm that it's a rhombus is check one pair of consecutive sides. Those are the sides that form a corner. Check this side, check this side. Make sure they're the same measurement, the same distance. Done. It's a rhombus. It's all you got to do. Okay? Now for a square. A square is a parallelogram with 4 congruent sides and 4 right angles. Think about that for a second. Which shape did we just talk about has 4 congruent sides? Yes, but before the square. Before the square. What shape are we just talking about? Before we talk, this the rhombus has 4 congruent sides, which means a square is a rhombus.
Is this a diagonal?
Yeah, it's leaned over on its side. Now, a square also has 4 right angles. Which shape also has 4 right angles?
Rectangle.
Rectangle, which means a square is also a rectangle. Yesterday, we were getting the identification cards. We were checking the ID of rectangles, right? That's what all this mess was. To see if we would allow that rectangle into our party, yes? Which means if a square walked in, could the square get into the party? Yes, because a square is also a rectangle, and if we're only allowing rectangles into our party, we have to allow the squares. Yes? If we were throwing a rhombus party and a square walked up to the door, would we have to let the square in?
Yeah.
Yes, because the square is also a rhombus. Okay? Make sense? Good. So, Venn diagram, just a picture of what it was that we just said. So, let me just chat about this picture real quick. So, here's the dance floor, the parallelogram club. All of the parallelograms in the universe are hanging out in this bar, having a good time. We have 2 dance floors. We have this dance floor that only allows rectangles, the things with 4 right angles. There it is. Okay? And in this dance floor, we only allow the rhombi, the things with 4 congruent sides. Do you see which shape gets to hang out on both dance floors?
Squares.
Okay, there it is. That's exactly what we just talked about. Good job. Turn the page. We've got 8 examples. Let's get through all of them. Yes, there's a figure here on the right, but because I need to zoom in so tight on what I'm writing to make sure you can see it, I'm going to draw the figure each and every single time I need it, okay? Okay, here we go. All right, Caesar, Juan, join us. We're going to be doing the examples. We're on the back of the page now. Celeste, you with me? Yes? Okay, good. All right, so here's my first quadrilateral, my first rhombus, ABCD, and I'm going to go ahead and put in the diagonals. All right, there they are. I'm told that the measure of angle ABD, so start at A, go to B, then go to D. This angle right here, this measurement is 60 degrees. I want to know what is the measurement of angle BDC. Start at B, go to D, end at C. I want to know what is the measurement of that angle. What do you think? How do you know? Yeah, it's the same size. What's telling you it's the same size?
The diagonal line on the other side.
Okay, so this diagonal right here?
No.
This one? Yeah? Okay.
It cuts it in.
Yeah, these diagonals are cutting the quadrilateral in half. We learned that from that parallelogram, that it cut this thing into 2 congruent triangles, which means those corners are the same measurement. You're absolutely right. This measures 60 degrees. Good job. All right, I'm going to redraw my quadrilateral here. There's my little rhombus. AE, I don't have an E on this picture, so I need to draw the diagonals. And I'm going to put in E as where those diagonals are intersecting. All right, I'm told that the measure of AE, that is this piece right here, is 8. And if I know that piece is 8, it wants to know what's all of that. What do we know about those diagonals? What do we know about the diagonals? Well, if this shape is a rhombus, it's also a parallelogram. And in a parallelogram, the diagonals cut each other in half. which means this piece is the same measurement as this piece. So if the pink side is 8, the not pink side is
8.
also 8. And so the entire thing is?
16.
Because you did 8 plus 8. Easy enough? Okay. Number 3. I need to draw my quadrilateral again. There's my very badly drawn rhombus. There we go. I'm told that the measure of AB, the measure of AB is 26. I'm told that the measure of BD, this entire thing, I'm told that that's 20. And I want to figure out what's this one. Now the issue with this is that I need more information. Looking at my properties of rhombi that you just copied down, I see that the diagonals are perpendicular. Okay? So that means that right here, there lives a right angle. Which means that this right here is a right triangle. Yes? I can use the Pythagorean Theorem to help me find information about right triangles. So I'm going to draw this triangle the best that I can. It's a very badly drawn right triangle. You can draw yours much nicer looking than mine. Or your right triangle can just look like however it looks like. Hey, focus please. Thank you. Okay, so draw your right triangle and we're going to label what we know. This is 26. This is, I don't know, so I'm going to replace it with an X. Now I need to figure out what this measure is. I'm told that all of this right here is 20. And since this is a rhombus, it's a parallelogram. And in a parallelogram, the rhombuses bisect each other. They cut each other in half. And so this piece right here must be half of the entire thing. And so this must measure the entire thing measures 20. I want just this one piece.
10.
10. Yeah, cut it in half. So now I can use the Pythagorean Theorem. I'm going to ignore the rhombus, and I'm going to look at just this right triangle, and I'm going to use the Pythagorean Theorem. Do y'all remember what the Pythagorean Theorem was?
These triangles are Rhombi.
That's triangle angle sum. We want Pythagorean Theorem.
A squared plus B squared plus C squared.
Equals C squared.
Yeah.
Yeah. A squared plus B squared equals C squared. All right. I left blanks because it's important to put the sides in the correct letter. This side across from the right angle is always C. The other sides, I don't really care what order you put them in, but C has to be the one across from the 90. Okay? All right, that means this is 10 squared. This is x squared. And this is 26 squared. All right. I may need some help calculating because I don't know 26 squared off the top of my head. You can see him frantically using his calculator app. Thank you.
676.
676. And then I'm going to need help again because I don't know what the square root of that thing is. a race to see who the calculator answers first. 24. All right, and that looks like what I was being asked for. So my answer on this one is 24. Questions on what I did? Ask them now. Yeah?
Now, where'd you get the 10 from?
Great question. I got the 10 from here. So BE is that little piece right there, which is half of this entire angle, or diagonal.
Oh,
Yeah. Okay. Moving on. We've been asked to find the measure of an angle CEB. Here's the rhombus that angle lives on. So we're looking for the angle CEB. This angle right there. That's the one we're after. But that angle is being created. Everything okay? Oh, okay. That angle is being created by two diagonals. And according to our diagonals of a rhombus, the diagonals are perpendicular, which means they intersect at 90 degrees. That's what that little box there means. Which means there's a 90-degree angle right here. And so the measure of angle CEB is 90. No algebra involved, no crazy adding or subtracting. Pretty cool, huh? We're halfway done. Good job. All right, A, B, C, D. I'm redrawing my rhombus every time, and it's getting messier each time I do it. If the measure of angle CBD, this one right here, equals 58, find the measure of ACD. This one, oh wait, ACB, yeah, this one right here. Okay, gonna zoom in on my diagram a little bit. Okay, do you see it? I have the red, I want the blue. There's a 90-degree angle right here because that angle is being formed by two diagonals. Yeah, at E. There's 90-degree angles there at E. When you add all the angles of a triangle, you get 180, which means that the measure of the red angle plus the measure of the blue angle, I don't know what it is, so I'm going to use X, plus the measure of that 90-degree angle there in the middle equals 180. And if I can solve that equation for X, I will have my answer. What do I need to do?
add 2 angles and subtract.
Yep, add the two angles, subtract from 180. Okay, do it and then tell me what my answer is going to be. 32. And to get this, we add 58 and 90, then subtract from 180. That's what we did. You can write that in words or you can write that in algebra. Whatever helps you, because these are your notes. We've got a few people copying down, and that's good. So while we wait for you, very happily wait for you, draw the rhombus for number 6. All right, zooming out. Here's number 6. I'm told that number 6, AE is 3x minus 1. So that's this piece right here. And then I'm told that AC, this entire piece, is 16. Find X. What do I know about the diagonals in this figure? The angles in the center of the diagonals are going to hit 90. You're right. What do we know about the links, the measures of the diagonals?
Is it like that supplementary?
Ooh, great insight. It is not. The supplementary happens at the consecutive angles at these two corners. Diagonals in a parallelogram bisect each other. That piece equal to that piece. So if those two pieces are equal, we can add them up to get to that 16, can't we? Okay? Thank you. So that's what I'm going to do. Yes. And then I can solve this equation for x. Yeah, easy enough? All right, let's do it. I am just writing the results of my steps. I'm not writing what I'm doing between each step. So please read through these steps and tell me if you understood what happened. I'm happy to explain what I did if you got a little lost. You got what I did? You wrote it down? ¿Y entendiste? Okay. ¿Suficiente para hacerlo sola? Okay. Vamos a ver. ¿Tienes tarea? Okay. Okay, so no questions on 6? No questions on number 6? Okay, good. Let's go on to number 7. We're almost done. We've only got 2 left, and we have like 20 minutes left in class, which is really good. We shouldn't take 10 minutes on each of these problems. That would be way too long. All right, so this one says, if the measure of angle CDB, so this angle right here, that's 6y, and the measure of ACB, this angle right here, is 2y plus 10. They want me to find y. Now there's a problem with this. The problem with this is while I know there's a right angle right here,
What did that say, Liz?
2y plus 10. Yeah, I've got it zoomed in really close and it's there. Is that a little better? There you go. That looks a little clear. Okay. So while I know that that's a 90 right here, and I know that this is 6y, I need information about that angle to use my triangle angle sum. And I don't have any information about angle, do I? Right? I don't have anything. But I have this figure from my notes. Remember that figure said that each diagonal bisected a pair of opposite angles. That meant that the 2 angles in here at this corner were equal, and the 2 angles at this corner were equal. You remember that? Which meant that this, since it's a rhombus, this diagonal makes this angle equal to this angle. So this angle is also 2y plus 10. And now I get to use the add them all up, they equal 180. Okay? So that doesn't seem anything new to add them up, but in order to justify why you're adding them, you had to go through that process that I just said.
Let's start with the one.
Yeah, when he gets back. Okay. I'm going to go ahead and walk through the different steps. Like the previous one, I'm not going to show the work between each step. I'm just going to show the results of them. Okay? So I'm going to ask you to read through that algebra and know what step I'm doing. And if you're not sure, just ask. I'm happy to tell you, okay? Okay. Okay. So there's my algebra work. Read through it. Make sure you understood how I went from one line to the next. We're okay with it? Questions on this one? All right. Last example, and then I promise we're done. All right, so give me just another few minutes of your wonderful focus and wonderful attention. I appreciate it. You guys have been really amazing today. All right, I'm told that AD in this rhombus is 2x plus 4. And I'm told that CD in this rhombus is 4x minus 4. Now, this being a parallelogram, if they were opposite to each other, I knew what I could do, right? But it's a rhombus. And more, I'm not given opposite sides, I'm given consecutive sides, the ones that form a corner. But I've got this little saying here that says in a rhombus, consecutive sides are congruent. Right? So in a rhombus, all four sides are congruent, aren't they? Which means this side has the same measure as this side, and so I can write my equation as 2x plus 4 equals 4x minus 4. Which then I can solve for x. I'm going to go ahead and solve this. Once again, I'm not going to write the work between the steps. I'm just going to write each individual step, okay? Again, please do ask if you're not sure where I'm coming up with a result. I'm more than happy to tell you what I did. Got some nods. All right, give me some votes. Thumbs up, you got this, you ready to start on the homework. Thumbs sideways, you've got some individual questions. Thumbs down, you want to work with me one-on-one. So just vote now when you're done. And as soon as I give you a nod at your vote, you are welcome to start on that homework. Go ahead. You got it. Go ahead. Good, go ahead. Okay, go ahead and start. Sal. All right, go ahead and start. Start. Oh, you and I were going to talk about 6-4. That's right. Yeah, you ready to start on this? Yeah? Okay, go ahead. All right. Okay, great. That's all I had for you guys today. Thank you very much.